Right, I wanted to make a quick video kind of demonstrating some core idea about complex roots. I'm going to build us up to it, and all of these things are solvable. They just not all of them have real answers. So if you kind of think back, we can solve squared problems like this first one by taking the square root on both sides, and I end up getting x equals positive and negative 2. And the reason we get both positive and negative is because, we can think 2 squared, well, that definitely equals 4, but also we know that negative 2 quantity squared, because negative 2 times negative 2 is also positive 4. So this answer has two parts. Well, not always do we get it so that it's super nice. We might have to move a value over to the point where we get like x squared equals 4, and then we kind of get the same thing. We have to take the square root of both sides, so x equals positive or negative 2. But we also might be in a situation where it's not equal to 0, that it's maybe equal to something else. And I just want to think about that quick scenario. So what happens if we add 4 to both sides here, plus 4? So then we get, I'm going to just rewrite it, x squared equals negative 16, and then we got to take a square root, and we get x equals positive or negative, because it's going to be positive or negative. But we run into this problem, and this problem is that you've always been told you can't take a square root of a negative number. Well, I'm gonna argue that yes, you can, if we rewrite this in this very special way, negative 1 times 16. And then we can think about it as the square root of negative 1 times the square root of 16, and the square root of 16 is a very normal known number. It's 4. So positive and negative 4 times this thing that we're not quite sure about, which is the square root of negative 1. So this is technically your answer, and we'll learn a little shortcut here in just a moment. I'm going to go ahead and skip this one so this video doesn't go on and on. But this is one of those core ideas, is that I can take a number and I can split it up and then rewrite it by simplifying the part that I can and leaving the part that I can't. I hope that makes a lot of sense. So something that I want to think about is when we're comparing graphs. So if I were to graph this function, x squared minus 4, I'd get this graph, and if I asked myself, well, find the roots of this thing, well, that would be a very easy task, because the roots are just the x-intercepts. Well, if I look at this separate function and I graph it, and I say, okay, y equals x squared plus 4, well, I hope you notice that it's really difficult to find the roots, because this function doesn't actually cross the roots. So we get something called a complex root, and this complex root idea is the core of this video. Now, if we were to solve for it, we would solve it in exactly the same way. We would say, if we wanted to solve for the roots, we'd say, okay, the y value is 0, and we're going to solve for x. So we're going to add 4 here, so we get 4 equals x squared, and we're going to take the square root, we get positive and negative 2 equals x. And then likewise, over here, we're going to set this equal to 0, but we know, based on the graph we just saw, that it's not going to reach 0. So we're going to get a funny answer. So I would have to subtract 4 like I normally would if I were solving. So negative 4 equals x squared. Well, we know that this is not possible, because when I take the square root, we're going to get x equals, I guess we could break it down into the square root of 4 times the square root of 1, and so x would equal 2 times the square root of that's a negative 1. And this is our answer, and it needs to be plus or minus, because I'm taking the square root, and it could be either way. When I plug it back in, I need to be able to be sure that I get this solution. And when I plug this in for x, even though it's kind of wonky, I'm going to get a true statement. So, well, what does this mean? So the major problem here is that we can't take the square root of a negative. So actually, mathematicians invented this fix, and they said, if this is the problem, taking the square root of negative 1, well, let me invent this concept called an imaginary number, and they called it I, and it can replace any value the square root of negative 1. So here it's plus or minus square root of negative 1. So it's really square root or x equals positive or negative imaginary number. Whatever that imaginary number is, we're going to hold off on what that is, probably for another course. Really, what is I and how do we deal more with it? So just a core idea here, and you may want to write this down because I think this is the meat of it, is that whenever I see the square root of -1, I know that that equals I. So I can replace the square root of -1 with I. So if I'm solving an equation like x squared equals -9, well, I'm going to do what I've always done. I'm going to take the square root of both sides. I'm going to get x equals positive or negative square root of -9, but we know that we can simplify that, and I'm going to simplify it below instead. It's positive or negative square root 9 times the square root of -1, and you might be able to say, hey, look, I know that the square root of -9, or square root of 9 is 3. It's going to be 3 times, and remember, we can simplify the square root of -1 to just be I, so I'm going to go ahead and do that. So the answer to this problem, the answer is going to be this positive or negative. There's two answers here, positive 3i and negative 3i. So there, you get two answers. So go ahead and pause the video and try solving these problems down below. Particularly with this second one, I want you to simplify it using your rules for simplifying radicals. So for this first one, we get x equals plus or minus the square root of 5i, and the I is not underneath the square root. That's really, really important. But this doesn't simplify anymore, so that's done. Go ahead and make sure that you're trying the other one as well. So I'm going to pause here. I've just started to solve the last one, and we get 6 root -2, and I got to deal with that negative, and so I really want to show you and make sure that you understand how to simplify. So it's plus or minus 6 times the square root of 2 times the square root of -1, and that simplifies to be plus or minus. So there's two answers here: 6 times the square root of 2, and then I. So there are two parts: the positive version of that and the negative version of that, and the I is not underneath the square root. All right, we can solve more problems like this, and I really want you to, take a moment to try and go ahead and simplify this idea. X squared plus 49 equals 0. We would want to subtract 49, and then we get x squared equals -49, and we need to take the square root, and you can hopefully start to, as you get better and better at this, equal positive or negative 7i, because the square root of -49 is -1 times 49, and 7 is the square root of 49, and I is the square root of that -1 part. So you can slowly simplify it more and more. I'm going to subtract 25, and this one's a little tricky because there's a fraction involved. So 9x squared equals -25, and we kind of have two options here. We can divide by 9, or we could, let's do that. Or we could just take the square root, but we're going to divide by 9. I'm going to keep it as a fraction because I want to, ensure that I'm simplifying it properly. So x squared equals -25 over 9. And if I take the square root of that thing, we're going to get x equals the square root of -25 over 9, which is the same thing as, it's positive or negative. So x equals positive or negative square root of -25 over the square root of 9 using our division rules, and I get x equals positive or negative 5i is on the top and 3 is on the bottom. And so it's a weird answer, it's a fraction, but it is correct, and we want to make sure that we're adhering to all of those properties that we already had learned previously. They don't go away because of imaginary numbers. I hope this video was helpful. This last problem was particularly tricky, but I think you can do it, especially if you're recalling all of your facts. Thanks for watching.